Okay. Yeah. And so therefore, if we want to measure a piece of land, how do we do that? Or measure how big is our bedroom? How do we do that? So when we talk about measurement, we need something called a unit. Okay. For example, if you want to say how tall you are, we're going to use inch as our unit. Now, if you want to see how tall maybe uh, a grass, probably we use something less than an inch. Or if you want to measure maybe a distance from your house to Washington, D.C., then inch is not enough. Oh, sorry, actually feet. We trying to measure, say, your height, we use feet. When we try to measure grass, then we use inch because grass is much shorter. Or if you want to measure distance from your house to Washington, D.C., then we're going to use miles. But no matter what, if it's long distance, our unit is 1 mile. For our height, our unit 1 feet. And for the grass, the one unit is inch. So that's called unit. So we call it unit. And we use that to see how many of those, or to kind of say for your height, we want to how many feet of that. So we're going to say, okay, this is 1 feet. We put another feet, put another feet. So we got 3 feet. And maybe this is shorter than 1 feet. Maybe this is just 10 inches. So we got 3 feet and 10 inches. So that's basically how we measure something in terms how long or how tall. Is basically, we call that one dimensional. So that's how we do it. But when we're doing area, we're actually talking about two dimensionals. So in order to measure that, we need a different unit. Now the unit we use is we got 1 inch. For example, this is 1 inch, 1 inch. So that's just what we call the unit, square inch. Or you could use feet. Suppose this is a feet, 1 feet, and another feet. That's called a unit square feet. This is a unit square inch. Or you need to know maybe how big Indianapolis is. So we're going to use, square miles for that. And if it's bigger, we use a bigger unit like acres, things like that. But no matter how what we do it, we always based on we call the unit um, measurement. We need a unit. So basically, that's our standard. We use that to measure. So now, if you have a square, then let's see. We got this side is 1 unit, this side is another one, and this side another one. So we got 3 units on one side. The other side, of course, will be 3 units. And total together, how many unit squares we got? And if you join them out, we actually got 1, 2, 3, 4, 5, 6, 7, 8, 9, which basically is 3 times 3. So that's where we got this definition for the formula for the square. Is basically we're talking about if this is the length and this will be our width. So like we did early on, we need to actually one side times another. That gives us how many of the unit squares we have. So therefore we have this basically is length. The area is length times width. And sometimes because the length and width is same, we use S instead. And because then each side is just same, S, 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 then the area is S squared. Good? Are we good here? about, all right, so we have that. And then, so this square will be the easiest what we are dealing with. Then we're going to get a rectangle. Now, rectangle is pretty easy because we just want to see, uh, we use the same formula because that's how many, because like say if we got uh, 3 units here and the other side, maybe we got 5. Well, how many unit square we have? You can see that 3, 3, we got 3 on this side and 1, 2, 3, 4, 5. So times together, we got 15 of those square units. So same area. We call this length and this is width. And sometimes we give a different name. We call that as the base and this is the height. So that's the same idea as length times width, but this time just write as base times height. Yep, good so far? Yeah, so those two are pretty straightforward. And based on that, then we can do the rest. Okay, so the next one we are doing on something called parallelogram. So parallelogram, as you can see that we actually, if we cut this part of it, the red line is our height. If I cut this and put on over on this side, and then we got a rectangle. Well, the rectangle we know is base times height. So from here to here, of course, that's our base, and we already know the height. So the area is base times height. Yep. Good here so far. Perfect. And then we got on to trapezoid. Trapezoid actually is, we know there's 2 lines parallel. So what we're going to do instead of just simply cutting it and put over because it may not work. So we're going to copy the whole thing and then put that upside down on this side. Well, now what we got here is called the bottom is B1, top is B2. And now you can see this side is B1 and this side is B2. So now we actually make a rectangle. Well, we know the rectangle formula is base times height, but in this case, our base is B1 plus B2 times height. But our trapezoid is only half of that, so that's why we divide by 2. So therefore, we have this formula, the area for trapezoid is base 1 plus base 2 over 2 and the times height. Good. All right. Okay. Now knowing that, knowing how to do parallelogram, which is very important for us, because once we know how to do parallelogram, you can see we can pretty much do the other shapes. Okay, so now we're going to get into a square, but not square, a triangle. Okay, triangle we got here. Well, triangle could have different shape. Now, it could have something like this. Okay. Yeah, like for this one, we can just cut half of that and put it on the other side. But for this, we just cannot do it. So we're going to do the same thing as we did for trapezoid. So we're going to copy the whole triangle and put that upside down. So we're going to copy the whole thing upside down. And what we got here is another parallelogram. So we know this is our base. So this is our same thing here, base and height. So we know the parallelogram is base, just base times height. Well, but our triangle is half of that, so we divide by 2. So that's where we triangle formula is area half base times height. Good. Hello. All right. So those you probably already know. So it's good as a review, but also help us understand why we have those formulas. Okay. If we understand the why behind the how, then uh, it's easy for us to remember the formula. Because if you forgot, you can always uh, uh, derive it. You can always just come up with it. Okay. So now we're going to looking at the other two quadrilaterals. The one is rhombus. Rhombus is looking like this. So do you remember the definition of rhombus? Yeah. Mia, do you remember that? Hello? Hello, Mia, can you hear me? All right. I can see that. Hello? Hi, Mia. You cannot hear me? Okay. All right. So, okay. Oh, so the no means you don't remember what's the rhombus, right? Okay. So the rhombus is basically we got uh, four sides exactly the same length, kind of just like a square. But the only difference is that the square, we actually, all the internal angles are triangles, right angles. But the rhombus, the area are not. So we actually get acute uh, angles on those two sides and also obtuse angles on the other side. Yeah, but it had the property that if you draw the line from the on this side and the left side and the right hand side, they actually symmetrical. Or if you can also draw on this line here, diagonal here, then the top side and the bottom side also symmetrical. Yeah, we good here so far? Okay, so now we're going to work on how do we derive the formula for rhombus. So what we got here is we basically got two triangles and actually two exactly the same length and same size. That's called congruent triangles. The top area is equal to bottom area. So we can either cut them like this, triangles, and find the area of the triangle, and then we just double that. Or we can do on the other side, we can do this triangle, find it, and double it. So, so we're going to looking at this one here. All right, and this is called diagonal, and this also diagonal. They have two diagonals, so we call the bottom one as D1, and the longer one as D2. Now, the nice thing about rhombus that is the two diagonals and actually cut each other in two. That's what we call bisect. So if bisect, then we know that this is D1 and this one here will be half of D2. And based on our formula for triangle, we know at the triangle, then the area would equal to half the base, which is our D1, and height, which is half of D2. And now we know this is this area, and the whole thing here, rhombus, is twice of that. So we got 2 times that, which is 2 times half D1 and half and D2. So we can see this got canceled, and we can move this half to the front. Then we got half D1 and D2. So that gives us the formula for the rhombus is half times the diagonal, then times the other diagonal. So is the multiplication of 2 diagonals, then divided by 2. Okay, good here so far? All right, very good. So now we're going to looking at kite. Do you remember what's a kite? Yeah. So what's a kite? Can you define it in your words? What? Not the formula, the definition. Definition for a kite. Yeah. So how do we know this is a kite and not other type, not a rhombus, not a rectangle? Yeah. Do you remember that? Well, uh, for a kite, well, just as a kite you fly, you can see that we got this side and this side congruent. So this actually is isosceles triangle. And also the bottom is also an isosceles triangle because this side and this side are congruent. So that's the definition for a kite, is that there's a pair of that side congruent, the other pair also congruent, but they are not, this side not equal to that side. Now, if this side equal to that side, then we got a rhombus. Okay, so basically we got 2 isosceles triangles, and to find the area, we want to add them together. So we have the top one is our A1, bottom one is our A2. Okay, the base here, use this one. It's a diagonal, it's called D1. And on here, let's call this one is our H. And on the other side, then will be D2 minus H, because the whole thing will be D2. From here to here will be D2. If this is H, then the other side will be D2 minus H. Okay, so now see what our A1 is. A1 is equal to half and times the base D1, then times height, which is H. And then A2 is also half times D1 and D2 minus H. Well, now you can see if we break the D2 into 2 parts, we got half D1 times D2 minus half D1 times H. Well, now you can see that exactly the same here. Okay, so our total area will be A1 plus A2. So A1 is half D1H, A2 is half D1, D2, then minus half D1H. So this part and this part are the same, so they cancel. So therefore, what's left is half D1 times D2. So therefore, we got an area for kite is also just like the rhombus is half the diagonal, one diagonal times the other diagonal, and divide by 2. Yeah, good. Very good. Okay, now I'm going to uh, ask you, so far when we went through that, and write out the formula for those shapes first, the formula for square. Good. So what's the formula for square? Yeah, you can just type it on the chat. Yeah, very good. So now let's do uh, a rectangle. Yeah, length times width or uh, base times height. Okay, so we got square, rectangle. The next one is the uh, parallelogram. Yep, exactly. Space time height. So the next one will be trapezoid. Yep. Well, it's not B1 times B2. Remember, we actually made that into two parallelogram. So it's half base one plus base two, then times height. Good. Okay, now let's do uh, triangle. Yep, very good. Half base times height. Okay, now we have two more left. One is the rhombus. So what's the area formula for rhombus? Yeah, actually it's half D1 times D2. Good. Yeah, you actually make another half. So it just half D1, D2. Okay, very good. How about a kite? Yeah. Hello, Mia. Well, it's for the kite, that's exactly the same formula as we did for rhombus. Is also half d1 times d2. Good. So the last one, the rhombus and kite, they have the same formula. Okay. All right. Now I'm going uh, have you do some practice. So we have those formula now. We got the triangle, square, rectangle, parallelogram, and we have rhombus and kite. Okay, so our first problem had to deal with a parallelogram, and we know it had the base, a parallelogram. We got the base is 10, and we have the height. So from here down here, for the height, height is 6. So what is the area of that? Yep, very good. That's the easy one. And then we're going to do something with some decimals, because in real life, things are not that neat. So 13.5, then the height will be 4.2. Very good. All right. Let's do, now we do trapdoid. The trapdoid, we got uh, it has a trapdoid. We got two bases. One is 12, one is 8. Then we got the height is 5. So what is the area? Yep, very good. Now we do something you have to solve the linear equation, just like you did when you learned that last year. So in this case, we know the area. There's still a trapdoor. We know the area. The area is 60, and oh, sorry, yeah, not 60, 84. That is 84, and its base is 10 and 8, and we want to find the height. Okay, so we're going to use the formula to help us to solve for that, right? We got trapdoid formula here. No, it's basically solving a linear equation. Very good. Good job. That's what it is. Very good. All right. So now we got into triangle. We got triangle. We have a base of 9 inch and the height of 7. And what is the area? Very good. Very good. Okay. Now we're going to change that a little bit. It's still triangle. We know the base is 15 and we don't know the height, but we know the area. The area is 60. We're trying to find the height. Yeah, very good. So the answer, the H is 8. Very good. Okay, so let's working on rhombus. Okay, so we have a rhombus. Rhombus, the all four sides are the same length, but they are not 90 degrees. The internal angle is not 90 degrees. Okay, we got this rhombus. We have a diagonal. One side is 16 and other side is 12. We're going to find the area. Well, you made a mistake there. So it's half 12 times 16. Now half 12 is 6. 6 times 16 give us 96. Good? Okay, great. And now we're going to do the other way around. We know the area is 50 and we know one diagonal. One diagonal is 10. So what is the other one? So with D1 is 10, A is 50, and we're asking for D2. 我在上课. Okay, very good. So our last thing is kite. Now the kite is made of two isosceles triangles. One is on the top and one is on the bottom. So in this case, we know one diagonal is 9. The other diagonal is 5. And what's the area? Perfect. Good job. Okay. Now we're going to do our last one. We know the area is 96 and one diagonal is 12. We're trying to figure out the other diagonal. Perfect. Good job. Good job. You did very well. Yeah, we actually went through this pretty quick. But those are the things we need to learn uh, in our in terms area. In the future, we're going to learn the area of like a circle and maybe part of circle is called a sector. And we're going to learn about the volume and also with that's 3D. So that's we call solid. So solids, we're also dealing with the surface area. Okay, so basically when we try to do the measurement in algebra, we're basically dealing with area and volume. Very good. So that's all for today. I'll send you homework, okay? And next week we'll do a unit one review, and then I'll send you the unit one test. Good. Yeah. By the way, you did very well on your homework. Okay. I'll see you next week. Bye.